Okay, everyone, let's get going here. This is Unit 1, Section 4, page 13 in your packet. If you don't understand what I said, you can scan that QR code and listen to the genius that wrote these worksheets explain it to you. So we're going to talk about exponent properties. We know we've done these in middle school. We did them already in high school. This is just a quick review. So for steps 1 through 3, write the real number property to justify each manipulation. Okay, let me see. -2 and then x to the 5th times 4 times x squared. And, -2, x to the 5th, 4, and x squared. Same order, but parentheses move. That's called associative. Associative, same order, parentheses moved. Put a comma there. Now, what happened here? Looks like the 4 and the x to the 5th changed order. That's commutative. Changed order. It's the commutative property multiplication is the whole thing. Now, you see the -2 times the 4 outside parentheses. Now they're together. So we have -2, 4, x to the 5th, x squared, -2, 4, x to the 5th, x squared. So the order stayed the same, but the parentheses moved. So it's exactly the same thing. Explain why the final exponent in the variable is 7. Yep, there we go. We did part A, check. Now we're doing part B. So explain why the final exponent of the variable is x to the 7th. Let me see. X to the 5th really equals 1, 2, 3, 4, 5. And x squared, get rid of that. Don't want to write down anything incorrect mathematically. X squared equals x times x. So x to the 5th times, again, x to the 5th times x squared is 1, 2, 3, 4, 5 x's, and 1, 2 more, which is 7 of them, doesn't equal 7. Boy, I'm having a bad day today. Equals x to the 7th. Okay. Students and teachers can forget their basic exponent properties used in simplifying a product to monomials because we tend to pick up on a pattern of multiplying numerical coefficients and adding the powers without thinking about commutative and associative properties to justify these manipulations. Find the product of each of the following monomials. So we're just going to warm up. Let me see. This is really 5 times 3 times x squared times x to the 6th, which is 15x to the 8th. -2 times -6, because I really like to put negative numbers in parentheses, and so do you. X to the 4th. Remember, there's really invisible 1 right there. That equals +12 x to the 5th. Yes, that is a 5. 3/2 times 6 is really 3 over 2 times 6 over 1. X to the 4th times x to the 10th. So that is 18 over 2 times x to the 14th, which is really 9x to the 14th. There we go. Oh, bingo, bango, bongo. This is 4 times 4 times x cubed times x cubed. That says write it down twice. 16x to the 6th. Remember, monomials, or terms, just one, it can be 16x to the 6th is a monomial. Can have more than one variable, just as long as they're all combined using multiplication division only, not addition and subtraction. Otherwise, it won't be a monomial. It'll be binomial, trinomial, etc., etc. Monomials and monomials contain more than one variable. Still, just involve the application of the exponent laws and repeated multiplication, commutative, and associative properties. Find each of the following products. Let's get down to work. So the first one here, we notice that there's no addition and subtraction, no addition and subtraction. We notice there's no addition and subtraction. So I can do this. I can do 4 times 5. Then x cubed times x, and y squared times y to the 5th. You can check them off as you commute them if you want. So this is 20, x to the fourth, y to the seventh. Let's get rid of that pen. So no addition or subtraction. So let's try -2 times -4. I'm just commuting, changing the order, changing the association. X to the seventh, x squared, y cubed, y to the sixth. 8x to the ninth. What am I doing? It looks like I am adding exponents and multiplying coefficients. Coefficients, number in front. Let's see if I can do this one in my head. 5 times 1 is 5. 2 times 2 is 4. We have x, and x squared is x cubed. We have y, and y to the fifth is y to the sixth. And we're done with page 13. Let's go on to page 14. On page 14, we're going to think a lot about factoring, okay? Factoring, let me see. Fill in this blank with what makes the product true. So let's think here. 2 times what is 6? 3. X squared times what is x to the fifth? I'm going to subtract those exponents. That's why we kind of warmed up there. X cubed. You can check if you want. 2 times 3 is 6. X squared times x cubed is x to the fifth. Good. Got it. 4 times what is 12? 3. X to the eighth is x cubed times what? Looks like x to the fifth because we're adding the exponents. We're multiplying the coefficients. 4 times 3 is 12. 3 plus 5 is 8. Now over here. -2 times what is positive 20? Uh-oh, must be -10. Negative times negative is a positive. Okay, now x times what is x squared? X times x is x squared. Right, 1 plus 1 is 2. 3 plus what is 4? 3 plus 1 is 4. Got it. If you have any questions, remember, ask me in class. Okay. The final skills we're reviewing this lesson using the distributive property. Okay. Use the distributive property to multiply the following monomials and polynomials. Ooh, polynomials. That must mean there's addition and subtraction symbols in there. Addition and subtraction symbols in there. That's a polynomial. Monomial, no addition and subtraction. Polynomials, yes, addition and subtraction. So let's do it. 2x times 5x, 10x squared. 2x times positive 3 is positive 6. Oh no, what do I do? There are no x's with the 3. Oh, that's right, you just put an x there. Oh, phew. Okay. So you see, 3 of the 2 x's is really just 2x plus 2x plus another 2x. That's 6 x's. 6 x's. It's like 2 candy bars and 2 candy bars and 2 candy bars is 6 candy bars. Not like 6 candy bars cubed. That's kind of, I know you can stack them and make them into a cube, but that's not what we're thinking about. It's like, what are you buying? What am I selling? 5x cubed times 2x squared. Okay, that would be 10x. Is it 6 or is it 5? It's 5 because you add the exponents. 5 times -3 is -15. X cubed times x is x to the fourth. 5 times positive 6 is positive 30. X cubed times no x's, we just went over that right there. It's just x cubed, it doesn't change. Nothing to combine, no common exponents, nothing to combine. -7 times, what number's there? A 1, it's a 1. -7 times 1 is -7. Then we have x squared times x squared is, be careful here, x to the fourth. -7 times -2 is positive 14. There we go. We're running out of time. Let me do the next ones quick. X cubed, y squared. Why is it y squared? Because there aren't any y's there. Minus x. Why isn't x is changing? Because there are no x's there. So y squared times y squared is y to the fourth. So I only combine like variables, okay? 3 times 2 is 6, and then x squared times x is x to the fourth, and then that's it. You don't do the x times the y. No, bad. You only multiply like terms in this monomial. And then it's y to the fifth. Now we do it all over again. Plus 3x cubed y to the sixth. I think that's a minus 12x squared y to the seventh. What did I do? I promise you I was going to be going faster here, but I can't. Okay, what did I do? I did 3x squared y to the fourth times 2x squared y. Then I took that plus sign, plus 3x squared y to the fourth times x y squared. Then I took that minus 3x squared y to the fourth times 4y cubed. Okay, so that 4y cubed went there, that went there, and that went right there. Hey, if you're confused, ask me, okay? Okay, I'm going to do A and B, and then we're going to call it quits. 4 times what is 8? 2. X times what is x squared? X. 4 times what is 12? 3. X times what is x? A 1. We really don't need that 1 there, but hey, it doesn't hurt. Does it say simplify? If it said simplify, we'd have to write 2x minus 3. 7 times what is 7? 1. X squared times what is x to the fourth? That would be x squared. And then we do a minus sign. And then 7 times what is 21? 3. X squared times what is x cubed? X, because 1 plus 2 is 3. And then 7 times what is 28? 4. And then x squared times what is x squared? Just a 1. We're going to leave that 1 out there. So let's just simplify. 1 times x squared is x minus 3x minus 4. There's the idea. If you are confused, make sure you ask me tomorrow in class. This is Mr. Bryce saying, see you later.